Hey everybody, Mr. Bucko here reporting from my basement because I cannot be there with you today. So I apologize for that, but I want to go over a couple things that are on Moodle for your notes for section 5.7 just to make a couple things clear, even though I can't be there today. So a couple things I want to go over here are in 5.7, which are the sums of angle measures and polygons. And what this means is we're just going to find out how many degrees are in polygons. And it's all based on triangles. And the triangle sum theorem, which comes down to that there are 180 degrees in a triangle. Any triangle you make has 180 degrees in it. And this triangle here, 65, 35, 80, those angles add up to 180. And that's true for any triangle that you make. Doesn't matter what those triangles look like, they will always add up to 180. And that's a crucial piece for the next couple of things that I'm going to talk about here very briefly. So if we have quadrilaterals, what we can do is, notice we have 4 angles in a quadrilateral, and we don't know exactly how big these angles are, and it really doesn't matter. This one looks like it might be 100 some odd degrees, but it doesn't matter because, for 2 reasons: it doesn't say how big it is, and 2, you don't say that because it looks like it. So what I'm going to do with this quadrilateral is I'm going to separate it into 2 triangles. Notice this quadrilateral now is made up of 2 triangles. And I know, or we know, how many degrees are in each of these triangles. In this triangle here, there's 180. And in the other triangle, there's 180. So therefore, in this quadrilateral, there are 360 degrees because we can break down the quadrilateral into 2 triangles, where we know each of those triangles is 180 degrees. So in the quadrilateral, there is 360 degrees because 2 of those 2 triangles make up that quadrilateral. So the quadrilateral sum theorem basically says what we just saw, is that the sum of the measures of the angles of a convex quadrilateral is 360 degrees. How about pentagons? Well, with a pentagon we can do the same thing. Notice in a pentagon we have 1, 2, 3, 4, 5 angles. Don't know how many degrees are in a pentagon, but we do know how many degrees are in a triangle. So what we can do is separate this into several triangles. And notice we go from this vertex out to here, and this vertex to this one. And then we don't need to go from this vertex to that one because that side already exists. Notice there are 3 triangles made up, and even though those triangles look different, we do know that all of them have 180 degrees in them. So if there are 3 triangles that make up a pentagon, that means that a pentagon must have 540 degrees because 180 plus 180 plus 180 is 540 degrees. We have a hexagon here, 6 sides. 1, 2, 3, 4, 5, 6. And what we're going to do is separate this hexagon into triangles. And notice, once again, I pick a vertex, and I go from one vertex to another vertex to another vertex to another. So I'm connecting one vertex to all the remaining vertices. And notice in this hexagon we have 1, 2, 3, 4 triangles. All of those are 180 degrees. I have no idea what these angle measures are, but I do know that all of them add up to 180. So in a hexagon, there is 4 times 180, which is 720 degrees. So in a hexagon, there are 720 degrees. So a general polygon, to wrap things up here, an n-gon. We know that a quadrilateral split into 2 triangles is 2 times 180, or 360 degrees. A pentagon splits into 3 triangles, 3 times 180, which would be 540 degrees. Hexagon split into 4 triangles, 4 times 180, which is 720 degrees. If we have an n-gon, we're going to split it into n minus 2 triangles. Notice there are 2 less triangles than there are sides. A quadrilateral has 4 sides, made up into 2 triangles. Pentagon has 5 sides, into 3 triangles. Hexagon has 6 sides, made up into 4 triangles. So if we have any sort of n-gon, 10-gon, 11-gon, 47-gon, there are 2 less triangles than there are sides, so you do n minus 2 times 180, and that will tell you how many degrees are in an n-gon. So there's a crash course there in angle measures of quadrilaterals. Hope that helps. These are your notes that are on Moodle. We will talk about this a little bit more on Friday when we review for our test, which will be next Tuesday. So, have a great day, everybody, and I will see you on Thursday. No, I'm sorry, Friday. Have a good day, everybody.